Test 2 review for the final. We're asked to find the slope of the tangent line to the curve at this function at 3, 1 exactly. So you might remember we've got both x's and y's in here. So what we're going to be doing is using implicit differentiation, and the slope of the tangent line is going to be dy dx, right? So we're looking for, could have just as easily said solve for dy dx. So we're going to take this function and we're going to do implicit differentiation. So the derivative of this first part is going to be, now it's a product rule, right? We've got x times y. So maybe I'll break it down a little bit more. 5x y to the fifth. So the first part, I take the derivative of x. Derivative of x is just going to be 1, right? So this becomes 5 y to the fifth. So I treat y kind of like it was a constant. So this is whatever. Plus, using the product rule, I leave the 5x there, and I take the derivative of y to the fifth. Y to the fifth, the 5 comes down. Highlight this. That's the 5 coming down. Then I've got y to the fourth. Since I'm taking the derivative of y, I put my marker of dy dx. Okay, when I took my derivative of x, I could have put d dx, but again, I think it gets in the way. So, but product rule here. For the second part, we've got this 3xy. We're going to have to kind of, well, we do the same thing. We have to use a product rule. So then we're going to have this plus derivative of x is 1, so we get 3y. Derivative of y is 1 dy dx. So the other part of the product rule, we get 3x dy dx. Maybe I should have changed colors, but I didn't. And then the derivative of 24 is 0. Okay, let's come back here. Let's clean things up. So we've got a 5y to the fifth, no marker. 5 times 5 is 25. X, y to the fourth, dy dx. And I guess that was a lot of work of copying just for that little piece. Well, while we're at it, I'll do a little bit more. I'm going to move these so that the dy dx terms are kind of next to each other. So I'm going to write this one first, 3x dy dx, because that's what we want to isolate, plus 3y. So I just swapped these positions. So we want to subtract everything that doesn't have a dy dx so that it gets to the other side. So those come over here. Right, so these are 0, these are 0. And at the same time, I'm going to factor out this dy dx. So I factored those out to the back side, and what that's going to leave on the front side is the 25 xy to the fourth plus 3x. Now, the best way to see this is if I distribute this back, I have exactly what I have. So I just factored it out. And then on the other side, I have minus 5y to the fifth minus 3y come up a little bit, and then all I need to do is divide both sides by this term here, right? So that this cancels and we have just dy dx equals, and then we want to find it exactly at 3, 1. So x is 3, y is 1. We replace those values in here, and then we'll get the numerical value. So minus 5, 1 to the 5th power, minus 3 times 1, 25 times 1, times 3. X is 3. Pay attention. There we go. And then y is 1, so that's kind of nice because y is the one that has the exponent on it. And then we've got a plus 3 times 3. Okay, so we get negative 5 here, right, because 1 to the 5th is still 1. 3 is 1. Negative 5 minus 3, that's going to give us negative 8. Okay, and the denominator, we got 25 times 3 times 1. That's going to be 75 plus 3 times 3 is 9. That's 84. Now that's correct, but can be reduced. Let's see. Does 4 go into 84? I don't know. Well, 2 goes into both of these, so that's going to give minus 4. 84 divided by 2 is going to be 42. 2 goes into both of these. 2 goes into 4 2 times. 2 goes into 42 21 times. So that would be the answer for that one. Okay. Let's see. We're supposed to use differentials to estimate the maximal error, and then what is the relative error?